Okay, so let's finish off matrix multiplication with example 6. So before the page, we said that switching the order in matrix multiplication does not give us the same answer because it's not commutative. There is one special case for which it is true, and that's when we're dealing with the identity matrix. So example A says, if A matrix is that, show that AI equals IA, where I is your identity matrix. So let's show that's true. So remember, in proofs, you always start off with what you want to show. So want to prove that AI is equal to IA. Now, remember, in proving, you always work with left-hand side equals blah, 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 and then separately do right-hand side equals blah, 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 and try to show that they end up with the same thing. So you make sure you just don't substitute. You don't blindly substitute in both sides at the same time. You can't do that. Okay, so let's start off with a left-hand side equals AI. Our A is 2, -3, -5, 4. Because A is a 2 by 2 matrix, our identity matrix will also be a 2 by 2 to match up the dimensions for multiplying, right? Because remember, identity matrix has to be a square matrix. And since we want the inner numbers to match up, the identity has to be a 2-dimension as well. So let's multiply row by column. So 2 times 1 gives you 2, 3 times 0 gives you 0, so 2 plus 0 is 2. Next, row 1 by column 2, so 2 times 0 is 0, -3 times 1 is -3. Next, row 2, column 1, you get a -5 and 0, which still gives you -5, and row 2, column 2 gives you 0 and 4, which adds to be 4. So we get a 2 by 2 answer, 2, -3, -5, and 4. And if you look close enough, that is exactly our original matrix A. Let's look at the right-hand side. We're looking at IA. So again, because A is a 2 by 2 matrix, your identity matrix needs to be a 2 by 2 to be able to be multiplied. So row 1, column 1, so 2, because 0 times -5 is 0. Row 1, column 2 gives me -3. Row 2, column 1 gives me -5. And row 2, column 2 gives me a 4. And lo and behold, that's exactly the same as the original matrix A. So therefore, left-hand side equals right-hand side. So therefore, we finish our proof by saying, therefore, AI equals IA, given that our A matrix was that there. Okay, so remember, identity matrix is kind of like number 1, right? Like, if you think about it, like 2 times 1 is 2, and the same is 1 times 2, right? So identity is kind of like the 1 in our number system, where anything times the identity gives the matrix itself back. And that's why we call it the identity, because it gives the original identity back. So IA equals AI, which is A, because the definition of identity matrix, and I is the multiplicative identity matrix. So it's like how we consider in our number system, where 1 is that special number where anything times 1 is itself. So yeah, just make sure when you do proofs or shows, you have a left-hand side equals and right-hand side equals separately, so that you show right-hand side equals left-hand side, and then you finish off with a statement of what you wanted to show or prove. Please do not just substitute blindly on both sides of what you want to show. That is very bad communication. That is bad ways of proving things.